Hello, welcome to the experiment number 3. Experiment number 3. This is the mechanics of practical and a simple pendulum. Simple pendulum. The condition of the problem is as follows. Kama tulivyoonyesha mchoro wetu, this is the diagram for the following experiment. The aim of the experiment is to determine the acceleration due to gravity. Set up the apparatus as shown in the figure. This is the figure which shows the condition of the problem. It consists of a thread, a little stand. There is a bench here, a height from the floor to the fixed point. There is a height from the floor to the center of the pendulum. So here it is. We have the height D is the distance from the floor, from the ground floor to the center of the bob. To the center of the bob is the distance is D. Whereby the distance from the floor to this fixed point, it is a height H. So then suspend a pendulum from the fixed point using a little stand such that a distance D is 100 centimeters from the floor. So here, it is 100 centimeters from the floor. Remember that we are measuring from the floor to the center of the bob. H is the height of the from the point of suspension to the floor. From the point of suspension to the floor, it is the height H. Then displace a pendulum through a small angle, theta, which is equal to 10 degrees, to one side, and record the time t for 10 complete oscillations. Then find the periodic time t, capital, for one complete oscillation. Vary in intervals of 10 centimeters to obtain 5 more values of D and repeat the procedure. Okay? Questions. Tabulate your task for the value of D, T small, T capital, and T squared. Remember that T small is the time for 10 oscillations, and T capital is the periodic time for one complete oscillation, whereby T squared is the periodic time squared. Then we are required to plot a graph of T squared in second squared against the L and against the distance D in centimeter. Determine the slope of the graph. Then determine the intercept along D axis. After then, what does the intercept along D axis above represent? If T squared is equal to negative 4 pi squared D over G plus 4 pi squared D over G is the equation for the pendulum. Calculate the acceleration due to gravity. Kwa hiyo tunayo equation of the pendulum, so we are going to use this equation to find the acceleration due to gravity. Okay, so let me start our experiment. So set up the experiment as shown in the diagram there. So this is a little stand containing a cork pad, containing a string, together with a pendulum bob. Also, we have a ruler for measuring the length, and also we have a stopwatch for measuring time. Okay. We are required to count a time for 10 oscillations. Remember that from the ground to this point, to the center of the bob, it is 100 centimeters initially. So, after then, you should tabulate your results as it is shown in this. This is the table of results containing the rows and columns. Rows and columns for the table of values. So, let me start counting 10 oscillations. For each 10 oscillations, recording time. Okay? So, 1, 2, 3. Start. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have 12.41. This is the time for 10 oscillations. Reset again, then vary the value of D in intervals of 10 centimeter. So here we are increasing 10 centimeter each time to obtain the value of D. Remember that we are measuring from the center of the ball. Measure from the center of the ball. Okay? So now, let me start again. 1, 2, 3. We are going to displace with a small angle from the point of suspension. So 1, 2, 3, start. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Here it is 14.41. 14.41. Again, increase the length of the pendulum by 10. Increase the length of pendulum by 10. You can put a mark. You can measure the length of the pendulum, length of the string, and put it into intervals of 10, so that all in all, our aim is to minimize error. So here, until 20. Okay. Let me count again. 1, 2, 3, start. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have 15.18. Again. And reduce it by 10, or increase the length of the pendulum by 10 centimeters. Okay. Again, let me start. 1, 2. 1, 2, 3, start. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It is 16.59. This is the time for 10 oscillations. I had 30 now, so now I'm going up to 40. So the good technique, they just measure the length of the string, then divide it into intervals of 10, so that it's going to be easier for you to reduce or to increase the length of the pendulum. We shall discuss about the errors resulting on a simple pendulum. Errors resulting on a simple pendulum. So, one, 2, 3, start. 1, 2. Oh, sorry. Okay. 1, 2, 3, start. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It is 17.79. And finally, a length of 15. Okay. So this is complete the last valve. Again, it's placed to a small angle. This placed to a small angle, then release. So 1, 2, 3, start. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It is 18.72. So these are the required values. After that, we shall determine the value of T capital, the time for one oscillation. Here we are taking the time for 10 oscillations divided by the time by the number of oscillations. For example, first I have 12.41. 12.41, just take it divided by 10, it will be the periodic time for one oscillation. For the case of T squared, you should square the value of T. Okay.